Hi, I'm Dominic Ravita, the field CTO at MemSQL, and I'm here today with Dendi Suhabdi from Bitwyre. He's a deep learning expert and co-founder of Bitwyre, an up-and-coming cryptocurrency exchange. Welcome,
Yep,
Dendi.
that's correct. Hey, well, thanks. Hi, everyone.
Yeah, so Dendi, before we get into Bitwyre and cryptocurrencies and what are they and what your company does, tell me a little bit about yourself, where you went to school, how you got into FinTech.
Okay. Yeah. For me, I I was a Fulbright scholar coming to the U.S. Circa 2014. I did my bachelor's here in Indonesia, and then like all undergrads, we all like dreamed to come to the States to do our studies, and got that scholarship. Was really really glad. Um, then came to NC State, and I got my master's there in mathematics. Uh, Worked with a famous mathematician whose working in the field of stochastic calculus, I believe, Dr. Tao Pang. And then after those 2 years, I decided to try my luck and send my resume, I guess, to Yoshua Bengio. Back then, deep learning wasn't as big as we know today, and then I was probably around the 100th student in the lab, which back then was already growing, and yeah, that's how I started being a student in the States and doing my like master's and PhD, and afterwards I decided to build this company, this crypto derivatives exchange called Bitwyre.
Yeah, and so the story of how you met Yoshua Bengio is interesting. How did you discover him and get into his doctoral program?
That's a pretty interesting story. It's so like I didn't know him, right, and he didn't know me, and usually you need to get an introduction to, at least you've worked with the computer scientist for at least 6 months. You usually get a research internship first before you get into a PhD program. But I didn't have any of that, so I finished during my last semesters of my master's, I tried to email him, and then he just said no. And then after him saying no a couple of times, I bet he was bored saying no to me. I just decided to, what if I fly to Montreal and try to convince him to become my PhD advisor. So I flew to Montreal. Of course, like after getting permission from the university and stuff like that. And then I met him at the parking lot. I still remember that day. I shook his hand, and then he said, like, come over to my office, and we had a chat. It was a fairly interesting chat, and then he said, yeah, just come on over and become my PhD student.
Yeah, that's amazing. That's persistence too.
Thanks. He did mention that too, and I was like, okay. So
well, maybe you figured as hard as you work to get into the program, you'd work at least as hard to not, to stay in the program.
Exactly. Yeah, indeed.
So one of the things you co-authored a few papers with Dr. Bengio, and one of the ones I came across was about a new kind of AI-driven chatbot that used deep reinforcement learning to simulate normal conversations. And tell us about that experience. I think this was a submission for an Amazon AlexaPrize.
Yeah, that's right. Yes, we like that was there's the Alexa competition, right? And there was a lot of universities around the world that were competing. Basically, Alexa's like conversational engine, I believe, and also the normal bot engine or conversational engine that we we know today are based on logic, the stuff that has been devised during the 80s and 90s, which, there's hard-coded logics. So I believe Yoshua and the team leader back then, who's an expert in natural language generation, or NLG, had a different idea. So we want to be the first team who's not going to throw these jobs to Amazon Mechanical Turks, right, or to these human annotators to tweak towards, what the customer wants. We want to try and do it so our system learn by itself, right, and gets the, as a human talking to another human, you don't want another human to like have a glitch a bit, like to check once in a while the dictionary, right? So we wanted a human learning system, and the closest we can get to that is, I believe, what's called the state of the art is the Julian Serban's paper back then. So we combined like 20 different models, I remember. So between
an ensemble approach.
An ensemble approach, that's correct. So there's multiple deep learning models, and then what we did is whenever a conversation comes in, Alexa has this module where it automatically converts to text, right? So they already solved that, and then we just needed to generate a response, and that response needs to be within a fairly good amount of time. If not, like you're not like talking to a real person, right? So
right.
We generated 20 responses, and we passed through all of that parallelized, and then ranked all that within that query response time frame. I think it was below a second, below a couple of milliseconds was the right response time, and then that ranked, and then picking the topmost one where our model is giving a response and giving back to the customer. Now, to rank the ensemble model, you need to fetch it to a couple of things. So we did fetch it to Amazon Mechanical Turks to determine if the response is as like natural or as human as possible. So we did have one model that I worked on called Escape Plan. So whenever like we didn't know anything, we just like put it back to the escape plan. Turns out at the end, there's the coefficient for the escape plan was so high, so the bot just escaped the conversation. It was so hilarious. But we tuned that down a bit, and then so after a while and also I'm pretty sure if you go online to see Julian Serban's video at Amazon's conference, we did a booth there, and then our bot was one of the highest. So people really like talking to our bot. So, and that was something new, and we realized that we're up to a thing with deep reinforcement learning. It was really fun.
Yeah, that's really interesting. That's really interesting. So while you were doing this super cool stuff in Joshua's lab, conversational agents, deep learning, novel things with NLP and NLG, you got the idea that you were going to create a cryptocurrency exchange. Yes,
I did. It started a while ago, since 2014, right? And we got I did a small thing here. Before everyone else, I printed a huge QR code. I generated our own like Bitcoin address and printed that on a huge QR code. All I did is try to knock doors of bar owners here in Jakarta, and told them, "Hey, do you want to receive Bitcoin?" That was 2014, right? And we sound like crazy, but apparently it got noticed by the community, and we got up on CoinDesk, so one of the largest publishers in cryptocurrencies, and we wanted to build firsthand a payment processor, because we really thought that if Bitcoin or crypto was invented in 2009, it's gonna be a no-brainer for at least in our opinion, that most people will catch up and everyone was starting using crypto. Right? Turns out that didn't happen until now, right? There's still a little infrastructure that needs to be built, and then the core infrastructure to build that is an exchange. So after a while, I tried my best to just hack our way through to build an exchange. No resource existed. So I was so frustrated in this journey of finding ways to build an exchange, and I tried to look up how CME does it, how NASDAQ does it, how NYC does it, and then there's only these stories, these stories of how they build the exchange. There's a very famous book going on, so I started reading electronic trading literature, and then Michael Lewis publishing.
Linus was one of his first popular ones, right?
Yes. Flash Boys, and then there was another book about Hayden Bodek and about dark pools, I think. Aaron Sorkin, I forgot who made it. And then apparently after all this, I realized there's this guy named Josh Levine who turns out built the core engine of NASDAQ called Instinet. And it was called Island back in the days, 1999. There was a Wired article about him, and I clicked on his website, and it turns out there's this. He explains everything. So he was depicted in the book. He was a kind of nerdy guy, like us, who was trying to really just understand how to build a market. It turns out his code is used throughout the world in various stock exchanges. So NASDAQ license their IPs to these stock exchanges to trade. Now it turns out his code fuels all of what we have today. That's and between that discovery, I realized that there's a significant problem in not only crypto, right, but the financial infrastructure that we have to build a future for crypto payments. Not only we need to have exchanges that are CME grade, but we also need to have payment systems that are geared toward crypto, custodian systems that are geared toward crypto. And from what I understand, what I know, and I might be wrong, the audience might know more than me, those kind of infrastructure does not exist today. So Bitwyre's vision is to make sure we transition not only from the exchange side, but for most payment system, exchange systems, from the old fiat traditional system to the future crypto money systems, and as our discussion last time about digital dollar, right, and the exciting things that Dr. Giancarlo is doing at the digital dollar project, where we're so excited that I think it's the right bet going forward.
Yeah. Well, for our listeners and audience who aren't familiar with what a cryptocurrency is, can you explain it in a nutshell, and also maybe its relationship to blockchain?
Sure. So imagine you own cash in your wallet, right? You have a $20 or $100 dollar in your wallet, and then when you pay someone with this, it's for the person who has the ability to bear this instrument. It's for example, if I give the cash to you, the cash is now yours, right? So it's called a bearer instrument. So computer scientists has tried so hard for decades to try to build this bearer instrument, because it's very, very important for us. For example, compared to PayPal, right? That you have and transfer money, it's not actually a bearer instrument. The PayPal authorities could decide if you're being paid or not. But like for crypto, it's a different thing. You really own crypto just like you own cash. So that's the gist of it, I guess. That's the very simplest way that I can do it. So whenever the analogy of having the cash in your wallet is you having this number, right? This huge number, and this number might sound confusing, but it's like it's simply what's called a private key, which you keep it as a secret, and then there's a public key, which is just a big number that you give it to someone else for everyone to transfer to that private key. So that's how I could like explain how I guess crypto works.
Right. And what's the relationship with blockchain?
Right. So blockchain is a technology that enables all this. So given you have these secrets, we can organize somehow a consensus system that you and I and other people save all of the list of the transactions on our own computer, so we know who owns which. So that's the, I guess, one really cool trick of solving this cash problem in this way.
Yeah, like a distributed public ledger.
Correct. Yeah, that's
right. Right. So you're using MemSQL to build out Bitwyre, but that's not the first data storage or database layer you started with. What did you start with, and how did that journey go, and how did you find MemSQL?
Yes. So yeah, that's really interesting. We from my experience and my friends in New York City, they mentioned if you want to go to trading, you should always do in-memory. And then the fastest decision I made, which is using Redis, right? And then so basically our exchange system, there's as if every like exchange system or trading system out there, there's the backend the backend is connected to the database system, right? So our whole operation, once we've done computing, we saved it to Redis, right? So we once initially it was okay when the insertion was like 10 to 20 orders per second, that was okay. But we really wanted to push forward the aggregate throughput, right, of our exchange. So once we tried sending, or like market fuzzing, that's what we call it internally, right? We try to send as much as order as possible within the very, very short time frame. Once that happens, after doing risk check, and then sending the orders or the trades that has happened to what's called the market data feed. So the clients need to know, hey, what trades has happened, and they're listening, right? So during that, we found out that Redis's concurrency isn't that great. Like the interface we keep writing to Redis and to the key value store using like the data structures that they provide. For example, the lists using lpush, rpush, and then we use the key like the set get or the h set and get. That was the query time was okay, but with the timeouts, it wasn't really great. So we kept getting these in what we call our feed engine. We kept getting these timeout errors. So then we tried a different thing. Maybe it wasn't maybe it was our code, right? So we try to use sync Redis, and turns out it still was there. So we just kind of, okay, maybe we didn't quite choose the right Redis. I did check with a couple of friends in India who also told me, yeah, we face the same thing when using Redis, and I was like, okay. So yeah, we then decided to okay, we made a big mistake. Let's go with this. Let's go to a SQL. Our CTO was just like, I have this relation with my CTO. He's just like laughing. He just said, "Hey, you should listen to me all this time. You should just use SQL." I was like, "Yeah, you're right." Yefta and I and another engineer of our school, Augie, we rewrote all of the Redis key value operations, hset, hget, and lvalue push into SQL, and the transition was really, really nice because whatever column that you have on your JSON, it's literally the same column in SQL, and then you don't need to do duplicate writes, because sometimes you don't need to do the lookup because you already do the insertion, right? Which is so nice, and especially with high dimensional data, you can just continuously add columns. Query times, we improved the query times by a lot. Actually, we improved the query times by almost aggregately, we improved the query time by almost half a second for aggregate everything. Yeah,
I mean, that's really meaningful in currency exchange. Half a second is a lifetime, right?
Yeah, half a second is a lifetime.
Dynamic changes of the value.
Yes. So for example, our message is really small, right? Less than 100 bytes. And then reading and writing that is around 400, 500 milliseconds. So it was from before, sometimes it times out and it goes more than a second. The problem with tradings is actually the probability distribution of what actually processing the orders. That's what I realize really, really matters, and the database choice we just rather go with in-memory SQL database, which we use MemSQL. It was right. It was a nice choice.
Gotcha. So it was mainly, it sounds like mainly on the read side that you were having the concurrency problem, but the write concurrency was working well, and now you've got both simultaneous write concurrency, satisfactory performance, along with this highly concurrent read process.
Indeed. Both write and read concurrency, that was really important. Indeed, that was.
And you're running this on a couple of nodes in what sort of infrastructure?
So we have our own bare metal infrastructure here in Jakarta. We didn't go through the cloud route, right? We chose to have our own, do it on premise. We ran on 3 nodes. It is on a virtualization layer, right? So we do manage our Kubernetes on bare metal, and then we put our databases on 3 nodes, basically separating according to trading functions. So for example, the gateway is 1 node for 1 cluster, right? So, and then for the matching engine and the risk check, that's 1 node. And then for also the custodian systems, that's also 1 node. And we do continuous backups every time. And then as you mentioned, with the full snapshot incremental backups to disk, which is really, really, really important for our operations.
Yeah, right, for sure. And how are your users interacting, or how will they interact? Is it through a graphical user interface? Is it through an API? Is it that and others?
Interesting. So both, exactly right. So we do provide a web interface, a mobile platform, both iOS and also Android. You could later check it out. Hopefully, it's going to be launching in a couple of weeks. So it's at https bitwyre.com/terminal. You can check it out. And yeah, we do that, but also for the very advanced algorithmic traders, we provide a trading API. So the specifications called the Financial Information Exchange. That's standard for most high frequency traders or quantitative developers. There's documentation online that we put out for public that they could just access it via an API key and API secret and just like blast their orders to us and start trading, I guess.
Right. Yeah. Cool. So you heard about MemSQL, it sounds like through word of mouth, some of your colleagues and your broader network, professional network, right? I'm sure probably other options were discussed at that point in time, like, in financial services and trading in particular. KDB Plus is a common thing. Did you take a look at that, and what was your experience with that?
I did take a look at that, and then the first thing that I guess the different syntactic programming language compared to SQL databases, right? I guess since like we're a startup, being able to conduct or like make develop code faster is something that's really, really important. And then us needing to learn Q and then also the interface of KDB Plus, even though with people referencing on performance numbers in KDB Plus, we do think that the interface does not fit our need currently, because that incremental investment to teach everyone Q and its interface is just we kind of think it might not be worth it at the moment. So there are several audience might have said, okay, well, there's interfaces between KDB Plus and Q. Why don't you use that for Python, for example? Yeah, there's not, so the support that they give for those interfaces are not exactly that great. And then just like having to instead of doing all of going through all of that hassle, decide to just use SQL. So it's just fast and like do things easily. So right. That's why we didn't choose KDB Plus.
Gotcha.
And also the pricing. So I did remember mentioning. So if we wanted to use it for commercial capabilities, we need the license wasn't particularly how do I say it? Particularly like cheap for like startups like us. I think affordable is the right way to say it. But for MemSQL, we could try it out until we exhaust the memory, right? And then we could like and the license is much more affordable for us. So that's why you chose it too.
All right, gotcha. And you mentioned that you had implemented Redis and you found really you were sort of getting a read concurrency bottleneck there. When you did the migration from Redis to MemSQL, what was that like? What was involved? How much time did it take? What's your experience in moving from Redis to MemSQL?
Yes, indeed. So the syntactic stuff that Redis has is quite so we had a bunch of JSON that key values that we need to store, right? It was really, really simple, as if we stripped out the keys and made them columns in SQL, and then use that to do the insert into or the select into queries that for MemSQL. We took probably like 2 weeks to do all of that for our whole exchange. So For comparison, our exchange is written 250,000 lines of code. So we did that in 2 weeks. So if we compare, like, there's probably 100 or less queries, like Redis read and set get queries, and then there's around 50 list pushes queries. So we change all that to SQL statements. We reduced it to around, we even reduced the number of queries to like around like 70, which made it much more faster. That's even without doing the optimizations that we should have done using SQL optimizations of like the tables and types and stuff like that. So that was already really. It took us 2 weeks and only like 3 people to do it. Yeah, it wasn't the experience of like porting our current Redis implementation to MemSQL operation wasn't that. It was as seamless as possible. It wasn't that hard.
All right, terrific. That's great. Yeah. And so in MemSQL, right, we support row stores in memory and column stores for analytics, which is memory and disk, right, and compressed in both. It sounds like today your workload is primarily with row stores. Do you see yourself doing, analytical workloads in the future with the column store?
Yes, we do. So using if we implement stuff for analyzing, like we did plan to use a couple of deep learning models in our trading pipeline, for example, to timestamp or like to flag an order if it's so-called it's violating market rules, for example. We timestamp and tell the trader, hey, like you should do this, right? There's this thing called velocity logic in the CME. So we implement the velocity logic using that actually. We run each order through a deep learning model, and if it flags Boolean 1, we go through. We use that the flag to save it not only in memory but also to disk, so both, and that so later on we can like look it up not only if we, because when we save it in memory, the backup would be happening like at the end of the day, but like at instance, if we do both the column store and row store, it would be saved like for like in disk as soon as the timestamp happens, right? So yeah, we use it for that purpose.
Gotcha. Right. And so getting back to Bitwyre, so you're going to be launching soon, within a few weeks or in a month or so. I mean, what's the unique set of differentiators that Bitwyre provides as a cryptocurrency exchange? I mean, there's not, to my knowledge, there's not a lot out there. I mean, there's Coinbase, which is maybe more well known than some others. But what does Bitwyre specifically do that makes it unique?
Okay, so we for the current like crypto ecosystem, there's a real need for having, first of all, the real need of having a CMA grade exchange, right? By that I mean having predictable latency when sending orders. I believe there has been numerous examples. I don't want to say which exchange, but several exchanges that did glitch when the price spiked too high or just dropped too low. We kind of don't want that to happen on our exchange, so we did a huge technological investment for everything, from networking to the database that we just discussed with you, and then to the matching engine. That's first, right? We want the network to be predictable, because that's really, really important to a lot of traders. Second, we want to allow dark and lit markets. So So for example, if you trade on NASDAQ or NYC, right? But if you have a large holding, you probably don't want to directly send orders to NASDAQ or NYC. You probably want to first send it to what's called a dark market. So a dark market is, or called ECNs back then, or dark pools, is if you have a huge portion of holdings, you want to liquidate them fast, or you want to buy things fast without causing market price changes a lot, which is called slippage, right?
Mm-hmm.
You shoot to these pools. Now, I'm 100% sure that there's less than 3 exchanges that run dark pools in this world. There's, I believe, the other one other than us would be Omega One, and they're catering towards the very high institutional traders. So not in terms of like the retail / whale traders that for crypto that usually exist. So that particular dark pool will operate, and the last one is the ability to do to settle crypto derivatives. You right now there's a couple of venues that you could sell crypto derivatives, right? Like the CME with the Bitcoin futures or options, but I guess the trader or the institutional trader needs to have choices, not only, for example, settling on the CME, but also settling on another exchange to do arbitrage, for example. And that, as in our long discussion together, Dominic, we've discussed it, that actually building this like implied markets and these products are not exactly that straightforward, right? And then we were just so glad to be able to technically execute that and probably offer those futures options, calendar spreads, and also later on, hopefully, the most exciting one is crypto interest rate swaps to traders. Yeah. So
you're targeting, if I could sum up, you're targeting the retail high frequency trader of cryptocurrencies.
Yes, indeed.
With no slippage in market pricing as they conduct these trading strategies.
Indeed.
And provide derivatives. That's super interesting and very unique.
Yeah, I think, yeah. Thanks. Yeah, I don't know if any group is working on that, but I think we're one of the frontier groups to work on it. Yeah.
That's fantastic. Well, Zindi, this has been a fascinating discussion, and thanks for sharing your story with the MemSQL community. And look forward to seeing the launch of Bitwyre.
It's my pleasure, Dominic. Anytime. We really appreciate it for allowing us to have you to do this interview with yourself.
Thank you. All right. Take care.
Take care. Bye bye.